We are now beginning the second portion of the review, and I'm going to go on with two problems of 11.2, and I started this before I graded your quizzes, and I'm finishing it after I've graded your quizzes, and I'm noticing there are a couple problems I need to do. So in the 11.2 section, I'm going to give you a problem. I'm going to make up roughly 3 plus square root of 3, 5 minus square root of 3. And we're going to look at how we solve that. So your first step is just to join FOIL. 3 times 5 is 15. And then I have inner plus 5 square root of 3. And then I have outer 3 times negative square root of 3 minus 3 square root of 3. Then I have last square root of 3 times negative square root of 3, which is now, this is why I'm going to do that. And I'm just going to put minus square root of 3 times square root of 3, because this is where most of you messed up if you messed up on your quiz. Now the square root of 3 times the square root of 3 is really just 3, right? Because the square root of 3 squared, that's what this is just going to give you 3. This operation, the squaring, undoes that. Now a lot of you put the square root of 9 and you left it as the square root of 9, but of course the square root of 9 is actually just 3, which is exactly what you find here. Okay, so we end up with 15 plus 5 square root of 3 minus 3 square root of 3, and that's going to give you 12 plus 2 square root of 3. Okay, I just wanted to do this one problem because I want to make sure you're going to have some like that on the test, and I'll make sure you know how to solve it. Okay, second thing, I'm going to give myself more space and switch papers, is problem number 16, page 755. And that is when the problem says the lateral surface area of a square pyramid with a height h, and you did this way back in pre-algebra last year, is given by L equals 2L, which is the base length, square root of 0.25 L squared. So again, that's the base length of a square pyramid, plus h squared. And just so that you remember what that is, a base pyramid, this looks like this, right? And here's it's square, so it's got 4 sides in the base. Looks like that. The height is going to be here. If I draw it, it's going to look very complicated. And the length of the base is this. Okay, so the lateral surface area. Now they're asking there to find the lateral surface area in square feet for a square pyramid with a height, so h equals 4 feet, and the length equals 4 feet as well. And they want you to find L. Well, this is just a substitution problem, which is going to involve square roots, which makes sense because that's what this chapter is. So 2 times 4, square root of 0.25 times 4 squared, plus 4 squared. Well, if we work all that out, we have 8 square root of 4 squared. Now remember, orders of operation, you can't multiply 0.25 by 4 first, because by order of operations we do exponents first. So it's really 0.25 times 16 plus 4 squared, which is 16. Well, 8 square root of 0.25, right, or a quarter of 16 is 4 plus 16, and I get 8 square root of 20, and I need to simplify that. Well, my square root of 20, and a lot of you made mistakes again on this on the quiz, is the square root of 4 times the square root of 5. Square root of 4 is 2, so 8 times 2 times the square root of 5, and I get 16 square root of 5, and this was in feet, I believe, or square feet. Okay, so that is number 16, by the way, as part of your review. And I'm going to go on to 11.3, which has some really the harder problems in all of this. So I'm going to start with, and I'm just going to do as many problems honestly as possible so that you get some practice working these out. So I'm going to start with number 18. And again, as I write these down, I strongly encourage you to pause the video, work it out, and then see if you did it right and catch your mistakes. That is how you'll know you're going to do well on the test. Oops, this should be a plus. Sorry for the mistake there. 34 equals 58. All right, to reiterate this problem, 8 square root of x minus 5 plus, sorry, I started to write equal too soon, 34 equals 58. What is my first step? Well, my first step is to subtract 34 from both sides. 8 square root of x minus 5 equals 24. I don't have yet my square root isolated on the side. In order to go on with this, I have to do that. So I have to divide both sides by 8. And I end up with x minus 5, square root of x minus 5 equals 3, because 24 divided by 8 is 3. I'm now to the point where I can square both sides to get rid of my square root on the left. When I do that, I get left with x minus 5. Move that up just a little, equals 9. And I'm going to continue over here. If I add 5, I'm going to get x equals 14. And that is the answer and the correct answer to number 18. If I checked for extraneous solutions and I substitute it back into my original equation, and make sure you write your original equation and you don't transform it too fast because you're going to want it to go back to check your solution. 14 minus 5 is 9. Inside the square root of 9 is 3. 3 times 8 is 24. 24 plus 34 is 58. So yes, this is indeed the correct solution. Okay. So actually, let me just go back and label that this was, we're now in section 11.3, which was about halfway through the review. Let's look at number 20. And number 20 says the square root of 5x plus 6 equals 5. Okay, so stop the video, start solving this, and come on back and we'll see if you did it correctly. Okay, to solve this problem, our first step is to subtract 6 from both sides. And I'm going to end up with square root of 5x equals negative 1. So I'm going to square both sides. But has anybody noticed what is wrong? And I wrote this too soon. Square root of 5x equals negative 1. Is that even possible? Could the square root of anything equal a negative? And I could actually stop right here and just say no solution. Because once I got to this point, I know that I can't get a square root that is a negative number. Let's go on to number 22. Number 22 says x equals square root of 2 minus x. Okay. So here, my first step is to square both sides, correct? Because I need to get rid of the square root, and it's already isolated on this side. It's not multiplied by anything or nothing's added to it. So I'm going to square both sides, and when I do that, I get x squared equals 2 minus x, and I can see that I'm forming a quadratic, and I want it to equal 0, so I'm going to add x and subtract 2, and end up with x squared plus x minus 2 equals 0. Well, fortunately, you can probably see that this can be factored, and that if I have a positive 2 and a negative 1, I will end up with a plus x in the center. So I get x equals 1, x equals -2. I'm going to try both of these answers in my original equation, which was x equals the square root of 2 minus x. Is 1 equal to the square root of 2 minus 1? In other words, square root of 1? Yes. So this is definitely a solution. Let's try -2. Is -2 equal to the square root of anything? Well, obviously not. So this is an extraneous solution. And my answer has to be just x equals 1. So that pretty much ends 11.3. And I'm going to go on to 11.4, which was just using the Pythagorean theorem. And there are a couple of questions that we're going to have for 11.4. The first is really simple, and that is finding an unknown lengths when we have two lengths of a triangle and we're told it's a right triangle. So if we're told it's a right triangle, we know right away that the Pythagorean theorem applies. A squared plus b squared equals c squared. And if we're told it's a right triangle where a equals 10 and c equals 21, we can use the Pythagorean theorem to find the value of b. So we're going to substitute this in. 10 squared plus b squared equals 21 squared. I'm going to grab my calculator because I don't know off the top of my head what 21 squared is. And 21 squared is 441. So I have 100 plus b squared equals 441. And so b squared is 441 minus 100. That's 341. I'm going to take the square root of both sides. And when I do that, I'm going to get, let's see, where my square root sign. I'm just going to raise it to 0.5, which is the same as taking a square root. I get 18.46. Actually, the book doesn't even do that. They'll just leave it as the square root of 341. So the answer for number 24 is a square root of 341. Okay, this video is getting too long, and which means it's going to take forever to load, so I'm going to pause it there and then finish 11.4 and do 11.5 in the next video to finish this review.